So in this video, we're going to begin the process of trying to understand Bayes' theorem, and we're going to begin with a rather morbid example. We're going to assume that we've got the three horsemen of the apocalypse: pestilence, famine, and war. And we've got a small community of 10 individuals that's been attacked, and we're trying to figure out which one of these possible culprits was really responsible. Well, we've got two additional pieces of information. We know that when pestilence attacks, typically 20% of the individuals are killed. When famine attacks, typically 40% of the individuals are killed. And when war attacks, typically 80% of the individual killed. In addition, we know that of the 10 people in this community, 4 died during the attack. And since we've got 0.4 here and 4 here, that suggests that famine might be responsible, but we don't know with any certainty, I should say. So now what I'm going to do is come down to this table. And so here we've got our 3 different horsemen, and this is our prior belief, our prior probability that a particular horseman was responsible. So in advance of getting any data, our prior probabilities would be each one of these has an equal likelihood of being involved, and these are nice probabilities. They add up to 1.0. So what is theta? Theta is the long run proportion of individuals that are killed when each one of these problems arrives. And so we can think of this as the expected value of mortality following an attack by one of these 3 different individuals. Of course, in any one attack, the observed number of deaths wouldn't necessarily reflect this proportion. It would be related to that proportion, but you could have more or fewer than what is actually shown here. Okay, so what do we have in this column? Well, obviously it's a conditional probability, and before going too far, let's think about what this really means. It's equal to probability that the number of dead is equal to 4, given that the horseman has some value of h. So as we saw in week 1, these things are random variables, and these are specific outcomes when the experiment is done. So if we think about what this thing means, it's the probability of getting a certain number of dead given a certain number of horsemen when the experiment is actually done. The other thing we can think about this is that it is a likelihood. And the concept of likelihood, remember, we think of P data given the parameters. In a likelihood, this is kept constant, and this is going to vary. So what we can do is we can calculate these values for each one of our different horsemen, and to do that, what we're going to use is the binomial theorem. So the data are going to be kept constant, and what's going to change is the value of the parameter, and in this case the parameter is going to be theta. So if we think about pestilence, what's the probability of getting 4 dead if pestilence was responsible? Well, according to our binomial, 10 choose 4, 0.2, that's our theta, raised to the 4, 0.8, raised to the 6, and that's going to give us 0.888. Oops, just 2 8s here. So, what we have here, we have in this column. Well, in this column, we've got the joint probability is being equal to the product of the marginal probability and conditional probability. And the way we saw this previously was, okay, one way to think about it is, if we want to be in a situation where we've got 4 dead and a particular horseman, first of all, we've got to have the probability of that particular horseman, and then we've got to have the probability of 4 dead given that particular horseman. So if we think about where this column is going to come from, we're just going to multiply this column by this column, and that'll give us this column. So 0.33 times 0.088 is going to give us this value here. Now we can move to this fellow. So this is the marginal probability of having 5 dead. Excuse me, having 4 dead. So that's the marginal probability. And there's a couple of ways to think about how we would arrive at this value of 0.1148. How can we have 4 dead? Well, there's really only 3 possibilities. Pestilence, and it killed 4, or famine, and it killed 4, or war, and it killed 4. So we add all these things up, and we get this value. Another way to think about it is what we saw earlier when we think about marginal joint and conditional distributions. The whole idea is if we wanted a marginal distribution, let's say the probability of a tree being a particular species, what we did is we started off with a joint distribution, probability of a tree being a particular species and height, and then we summed over all the different height classes. So that's how we arrived at this value of P4. And then now we move on to this column. And that shouldn't be too strange, because what we saw before is if you think about the probability of H given 4, that would be arrived at by taking the joint probability and dividing it by the marginal probability. Or the other way to think about it is, if you took this value and you multiplied it by this value, that would give you that value. So that's the origin of what we're seeing in this column here. So what's going on here? What's going on here is we're taking each one of these values, we're dividing it by this value, and that's going to give us these values. Now, nice thing about these particular values here is that they are nice probabilities. They sum up to 1.0. Something else that's happening is that if we think about, if we were to think about the proportions here, they're exactly the same as the proportions here, because we get from here to here by dividing by a constant. So we can think about this constant here in a sense of being, as being a normalizing function that takes these values and converts them to something that adds up to 1.0. Now, this column here is really a critical column, because what this reflects is our posterior probabilities. So, to review, we started off with some prior beliefs. We thought that each one of these horsemen with their particular mortality rates were equally likely. So that was our prior belief. And then we got some data. And the data was that 4 out of 10 were killed. And then we did a whole bunch of calculations, and what we arrived at were the posterior probabilities that these particular individuals might have been responsible. And the results here are quite realistic in the sense that, okay, famine kills 40% on average. We observed 4 out of 10. So our prior probability was 0.33 for famine, but after getting this particular data, it jumped all the way up to 0.7283. In contrast, if we think about war, which initially was as equally likely as famine to be responsible, it typically kills 80% of the people. So given that only 40% mortality occurred, the probability that war was the responsible culprit has dropped substantially from 0.333 to 0.0160. So the whole idea is we have some prior beliefs, we collect some data, and then we arrive at posterior probabilities by adjusting our priors based on the data.